Right, so welcome to this class. We are looking at questions from Tutor Sheet 2. Okay, so if you have any questions, please feel free to ask. Okay, so this is Introduction to Statistics and Probability, and specifically today we'll be looking at the statistics part. So there's some concepts that you need to know. Okay, so we'll be looking at question 2 and 3, and then the other ones, I'll still upload them once I redo the video. Okay, so we start from question 2 there. Okay, so it's just a simple question, but there's a lot to do there. Okay, so here they're saying 3 hospitals recorded the following number of deaths per month over a period of 18 months. Okay, so this means in the first month, there are like 6 deaths, second month, 8 deaths, just like that. Okay, so this was the data collected for the University Teaching Hospital, which is UTH. And then we have Kitwe Central Hospital. It had this following data. Ndola General Hospital, it also had this number of deaths for the period of 18 months. Okay, so now the question is find the mean, the median, the mode, the interquartile range, the mean deviation, the standard deviation, and the coefficient of variation for each of the hospitals above. Okay, so what we are going to do here is that I'm going to calculate all these for one hospital. Okay, so it means that I would have shown you how to do it. And then for the other ones, you can do it on your own. Okay, but I've already done them and I found the answers. So these are the answers that we're expected to find. So like for UTH, we should find the mean this, the median that, the mode that, and the rest of the things. So I'm going to show you how to find all these using the data for the UTH. Okay, and then for KCH, NGH, you can do it on your own, but you should find the answers that I've put there. Okay. All right. And then based on the data that we have there, okay, we can compare the variations of death in the 3 hospitals. Okay. So the one that was the highest coefficient of variation here, okay, will say that a lot of deaths were taking place in that hospital. Okay. And then C, they're saying which hospital needs a doctor urgently of the 3 hospitals that we have. And then they're saying give your reason for your answer. So the hospital that would need the doctor urgently will be the hospital that has the largest variation. Okay, so it means that that hospital, maybe the healthcare is not that good. Okay, so they need um, an extra doctor. Okay, so that's what we are going to do. So let's pick up the data for UTH and then try to find all these things that they've mentioned here. Okay, so we start with the UTH there. Okay, so how do we find the mean, the median, the mode? Okay, so the first thing is to arrange the data that we have here in increasing order. Okay, we arrange it in increasing order. So meaning from the lowest to the highest. Okay, so in this data here for UTH, you can see that the lowest is 3, this one here, and then the highest is 17. Okay, so I can start writing them here. So I'll say the lowest is 3. Okay, and then from 3, I can see 2 5s. So I have this 5 and that 5. So I'll just write 5 and another 5. Okay, from 5, I see the next number 6. So 6, how many 6 do we have? I have 1, 2, 3, 4. So I'll put 6, 4, 6 here. Okay, I don't know if that English is correct. And then from there, can I see a 7 anywhere? Okay, I don't. I can just say an 8. So 8, how many do I have? 1, 2, 3, this one. So write these 8s 3 times. Okay, and then from there, I go to 9. How many 9s do I have? So I have 1 and 2. So I'll put 9 and 9. Okay, and then from there, do I have any 10 here? I can't see any 10, but I can see an 11, and it's only 1. So I'll just put 111 there. Okay, and then I go to 12, so I have 1, 2. Okay, so I'll just write 12 and another 12. And then from there, I'm going to write the 15. So 15, I only have 1. Okay, and then 17 and 17. Okay, so I've ordered my data, okay, from the lowest, which is 3, this one, okay, to the highest, which is what? 17. Okay, and then from there now we can start our calculations. So the first thing that we have to find here is the mean. Okay, so how do you find the mean? So the mean, which is indicated by x bar, will just be equals to the summation of all these entries that we have. So we can call them x divided by how many they are. So we call it as n. So this data was collected over 18 months. So these entries are 18. So our n is 18. And then the summation of all this, okay, I'll just punch them on my calculator. So you should also confirm with your own calculators. So I'm just adding them. So 3 plus 5 until I reach here. Okay, so when I do that, I get 163. So I'm just adding all these things. Then divided by the n, we said it's 18. Okay, so we divide this, I get 9.0556. We can round this off to three significant figures. I'll just get 9.06. So this is the mean for the hospital UTH. So you can see in my table here, okay, I found my answers. We have found that 9.06, this one here. We have shown how to find it. Okay, so if you have any questions, please ask. Okay, from there, we are going to calculate now the median. Okay, so we know that the median is the middle value. Okay, and if we are to be accurate, okay, we use the formula for the percentiles. So the median is the same as the Q2, which is the what? The 50th percentile. Okay, so we're going to use that formula. So the position of a certain percentile is equals to K over 100 multiplied by, okay, K over 100 um, multiplied by N plus 1. So this K is the percentile that you want to find, which is the 50th percentile, this one. So I'll say this is equals to 50 over 100, okay, and then 18 plus 1. So this will be here 50 divided by 100, that's like half. So half multiplied by 19. Okay, so half multiplied by 19, what am I going to get? Okay, what am I going to get when I do half multiplied by 19? Okay, let me do that. Or maybe we can just use the other formula, but I want to get an accurate approximation. So 19 divided by half, okay, 19 divided by half, I get 9.5. Okay, so it means the position for the 50th percentile, which is Q2, or in other terms, the median that we want, okay, is at position 9.5. So if you find a decimal place, okay, or a decimal number, okay, we can't find the position 9.5 in this data set. So what do? We use what we call as interpolation, okay? So interpolation says that this 9.5, I'm going to divide it into two parts, okay? So I'm going to say my Q2 will be equals to, okay, the X value at the ninth position, okay? And then I say plus, so 9.5 minus 9 to give me 0.5. Okay, and then I multiply this by the X value, which is on the 9 plus 1 position. Okay, so 9 plus 1, this means the 10th position minus the uh, the X value on the ninth position, like this. So we're using interpolation here. So what is the value on the ninth position? So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9 is this 8. So I'm going to write 8 and then plus 0.5, and then the um, the value at the 10th position is this 8. So this will be 8 minus 8. Okay, so 8 minus 8 is what? It's 0. So it's 0.5 multiplied by 8 minus 8, which will just be 0. So it means the answer here will just be what? 8. Okay, so the median here is 8. So you can see here what I found as my median. Okay, so the method that I'm using here is going to give you the correct answer, like the accurate answer. Okay, but if you want to use approximations, there's another method. I'll show you later. Okay, so that is the median. We found it to be 8. Okay, our median is 8. We're done with that. So if you have any question, please ask. Okay. All right, and then
Mm.
there. Okay, someone has a question. Yes?
Yeah, a bit fast. Yeah, a bit fast on this one. Kindly repeat
Okay. All right. So I repeat which part?
the Q2 part.
Okay. So here, the question here, we are trying to find the median, right? So the median is the same as Q2. Okay. It's also the same as the 50th percentile. So we are using the formula for the percentiles to find this median, okay, because we want to find the accurate median. So to find the position of a certain uh, percentile, we use this formula here. Okay, where K is the percentile that you're interested in this case, the 50th percentile, which is the median. And then N is the number of values that you have in the data set. So in this data set, we have 18 values. Okay, that's the 18 that I put on N. And then the K is the 50th percentile. So when I did this, I found 9.5. So 9.5 is not a position anywhere here. Okay, it's not a position anywhere there because you can't find position 9.5. The position can only be it can only be a whole number. It can be 1, 2, 3, like that, right? So when you find that the position is a decimal number, you use what we call as the interpolation. Okay, so interpolation says that you get the x value at the ninth position, so whatever number that you have here before the decimal point here. So if it is 11 here, you get the value at the 11th position. Okay, so this is what I wrote here, ninth position, the x value at the ninth position. And then you do this value that you have here down, this 9. Okay, you subtract it from the 9.5 or whatever number that you have here. Okay, so 9.5 minus 9, it gave me a 0.5. So that's what you write there. And then in the brackets, you're going to say the x value that is one step ahead of this ninth position. So that is the x value at the 10th position minus the value at the ninth position. That's what I did there. Okay. So now the value at the ninth position, you just count in this organized data set that you have. Okay. It gave me this 8. So I wrote 8 and then plus the 0.5. Okay. And then in the brackets, I have this value at the 10th position minus the value at the ninth position. So here it happens that the value at the 10th position is also what? 8. So here inside the brackets, I'm doing 8 minus 8. So that is 0. 0.5 multiplied by 0, that is 0. And then 8 plus 0, it's still giving me 8 there. So that's how we found the mean there. So I don't know if it's clear there. Is it clear?
Yes, it's clear now.
All right, so we are going to do a lot of interpolation. So you are going to get it
I
by the
have a
time we are
question.
finishing. Yeah, someone has a question?
Yes, the answer that you got, 8, is it the eighth number, the eighth position in the data set?
No, it's the actual value. It's the actual value. This 8 here is the actual value for the median. So you can see here I wrote 2q. Here I wrote the position. Okay, so the ones that are indicating the position are these ones, x9, x10, x9 again. They're the ones that are indicating the position.
Oh, okay, thank you.
All right. All right, so you're going to get this method. I know maybe some of you it's new using interpolation, but when you find the Q1 again, the Q3, you're going to get it. Okay, so we found the median, which is this 8 here. So now let's find the mode. So the mode is very simple, right? Everyone can find that. So the mode is just the number that is appearing more frequently. So we see here that the mode is what? This 6 here, because it's appearing uh, 4 times, which is more than any other number. So that's the mode that I put there. Okay, and then now we're asked to find the interquartile range. So the interquartile range is equals to Q3, okay, minus Q1. So this is the upper quartile, the lower quartile. So how are we going to find these quartiles? We are still going to use this formula that we're using here, okay? So now the Q1 is the same as the 25th percentile. Okay, the Q3 is the same as the 75th percentile. So you have to know this by heart. So Q1, 25th, Q2, 50th, Q3, 75th. So now let's find the Q1. Okay, so I'll erase this. So the Q1, okay, using the formula for the position, using the percentile. So position will be equals to, okay, the percentile that I'm interested in this case is 25 over 100. then multiplied by the n plus 1. So the n is 18 plus 1 is 19. So this will just be 25 over 100 multiplied by 19. So what are we going to get there? Okay, so let me punch this on my calculator. So I have a 25 divided by 100 multiplied by 19. So here I'm getting 4.75. Okay, so this is a decimal number. We can't have such a position. So for us to find the percentile, okay, for the 25th percentile, we're just going to say Q1 is equals to the value of X that is at position what? 4. You get the number before the decimal point, 4, and then um, you say plus, okay? And then you say this 4.75 minus this 4 is going to give me what? 0.75. Okay. And then in the brackets, I'm going to have X at a position which is one step ahead of this. So it will be X5, okay, minus X4. So that's what we do there. Okay. I'm sure you have started getting it right now, right? So we get the X value at position 4. So X value at position 4 is which one? So 1, 2, 3, 4. It is 6. So I write 6 plus 0.75. Okay. The X value at position 5, it's what? The X value at position 5 is what? It's still 6, right? Because this is 4, 6. Okay. I mean, this is 4, 5. So the X value here is still 6. So here inside I have 6 minus 6. So this will just be what? 0. Okay. So my Q1 will actually be what? 6. Because this here will just be 0. Okay. So we can keep it. Q1, it's 6. Let's find the Q3 using the same thing. Okay. So here I'll just erase the top part there, and then the top part there, and then the final answer there. Okay. And then I can erase whatever is down here. So the Q1, we found it was 6. Okay, let's try to find the Q3. So this would be 75, 75. Okay, so now I have 75 divided by 100, okay, then multiplied by 19. So I get 14.25. So now we use interpolation to find the Q3. So it will be Q3 is equals to, okay, the X value at the 14th position. So I write X4, and then I say plus 14.25 minus 14. I get 0.25. And then the X value at a position ahead of this 14 by 1. So that will be 15 minus X 14. So this will be equals to which value is at position 14? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 is this 12 here. So I write 12. Okay, plus 0.25. Okay, and then inside here, what am I going to have? So the 15th position as what? The 15th position as what? Okay, why is it not adding up here? So this was 14, 15. So I still have 12 minus 12. Okay, so this one here will be 12, and then here it will still be 0, right? So it will just be 12. Okay, so Q3 will just be 12 like that. Okay, and then we can subtract the 2. So I'm going to erase this part. So the interquartile range will be the Q3 minus the Q1. Okay, so that will be 12 minus what? To be 12 minus 6. Okay, so here I find 6. Okay, so I don't know why I found 5.5 here. Because it's supposed to add up with whatever I was finding there. Okay, so in this case, we find 6. So we've shown how to find this 6. So I'll correct this part here. Okay, any questions there on how we found the quartiles? Any questions there?
Sir,
On our... Yes?
sir, I have a question.
Yes.
When finding the position that has got my decimal points, isn't there any other formula that is easier to find these rather than using the interpolation?
No. Like, I don't know any other formula. I've always been using the interpolation formula. Yeah. So if you know it, if there is other one which is easier, you can share it with me after the class. But I've not looked at any other formula which is easy.
Thank you, sir.
All right. I've always used the interpolation. Okay, so now we find the mean deviation. Okay, so the mean deviation, it has a formula. Okay, so the mean deviation is the summation of the modulus of each x value minus the mean. Okay, and then you divide by the number of observations that you have. Okay, so the formula that we are going to be using is this one here. Okay, so the mean deviation, so I'm just write MD is equals to the summation of the modulus, okay, of each x value, so each of these values here, minus the mean, okay, modulus, and then I divide by what? By n, which is the number of observations. So this will just be equals to, so I have to say this value minus the mean, okay, its modulus, plus this value minus the mean, its modulus, plus just like that. So it will be, okay, 3 minus the mean, which we found was 9.06 modulus, plus 5 minus the mean, modulus, okay, plus another 5. I can see another 5 there. Okay, so if there are two 5s there, we can even just add a 2 in front there because it will give us the same value. So for the 5, since there are 2, I'll just write 2 and then 5 minus 9.06 like this. So I've cut out for this and this. For the 6, there are 4. So I'm going to write plus 4, the mean deviation, 6 minus 9.06. Okay, then plus from the 6 we go to the 8. So the 8s are 3. So I write 3, then 8 minus 9.06 modulus. Okay, I'm still adding, plus I go to the 9s, they are 2. So I just write 2, 9 minus 9.06 plus 11 is just alone. So I'll just write it the way it is. Okay, and then plus the 12s are 2. So this will be 2. 12 minus 9.06. Okay, plus 15 is just alone. So it will be 15 minus 9.06 modulus. Okay, plus, and then I have two 17s here, this one and this one. So it will be 2, 17 minus, now I've run out of space. Let me do this. Okay, so 17 minus 9.06 there, modulus, okay? And then the summation of all these things, I'm going to divide them by what? By n. So n was 18. Okay, so now you just have to go to your calculator. Okay, you go to your calculator and then you add those things and then you divide by what? By n. Okay, so so when you do that, you should be able to get the mean deviation value of 3.2963. Then you can round this off. Okay, you get 3 point. If I round it off from here, okay, even from here, I still get 3.30 like this. So this was the value that I found when I was solving, which is this one that I put there. Okay, so that's what you do there. So any questions on the mean deviation? Okay, so here, these moduluses simply means whatever value that you're going to find inside here, okay, whether it's positive or negative, you take it as a positive number. Okay, and then you just add them and then you divide by 80. That's how I was able to find this guy here. Okay, so any questions there? Okay, if there are no questions, let's go and find the So we're finding the mean deviation. Now we find the standard deviation. Okay, so the standard deviation is just the square root of the variance. Okay, so if you don't know how to find the variance, you can't calculate the standard deviation. Okay, so you have to, uh, I always say you have to master the formula for the variance. And then for the standard deviation, we'll just be getting the square root of the variance. Okay. Okay, so don't even worry if you don't know the formula for the standard deviation. Okay, as long as you know the formula for the variance, okay, you find the variance and then you take the square root. That will be your standard deviation. Okay, so the variance is equals to, okay, 1 over n minus 1. And then we are going to say the summation, okay, of xi. So this xi simply represent all these x values that we have there. Okay, and then minus the mean and then squared like that. Okay, so we are doing somehow a similar thing to what we are doing on the mean deviation. But here it's just that the difference between each x value and the mean, we're going to be squaring them. Okay, so that's what we are going to do there. So let's write this. Okay, let's solve this. So I'm going to say, okay, let me move this thing a bit this side. Okay, so variance there is going to be equals to, okay, I don't know if, are you seeing if I, if I zoom them out like that? Are you able to see if I do this? Hello? I want to create more space for solving. I don't know if you're able to see. Okay, so,
Yes, sir.
all right, that's good then. So let's find the variance. So the variance will just be equals to 1 over n, which is 18 minus 1. Okay, so that would be like 1 over 17. And then now we start adding the squares, the square differences of all these things with the mean. So the first one, okay, it will be 3 minus 9.06, and then I say squared, okay, plus, so use the same trick that we used on the mean deviation for these guys that are repeating. So here I have 2 5s. So I'm going to say 2, okay, and then 3, 5 minus 9.06 squared plus the 6, I have 4 of them, so I'll write 4, 6 minus 9.06 squared plus the 8, there are 3, so 3, 8 minus 9.06 squared plus, I go to the 9s, so the 9s are what? Okay, so I'll say this whole thing is in a big bracket, so plus the 9s are 2, and then 9 minus 9.06 squared plus 11 minus 9.06 squared plus 12. I have 2 of them, so 2, 12 minus 9.06 squared plus I have 15 minus 9.06 squared, and then plus 2 for the 17s. Okay, so what is remaining there is just for you guys to punch this onto the calculator. So I have, okay, I have 19, or I have 1 over 17, I mean, okay, and then whatever sum that I'll get here. Okay, so I'll just write the sum there, and then I'll punch these guys onto the calculator. So the sum of this, so you do 3 minus this squared, 2 multiplied by this squared, just like that, and then you get a sum here. Okay, so let me do it on my calculator. Okay, so also do it on your calculator. So we just confirm the answers. Okay. Okay, so when I do it on my calculator and then I divide by 17, I'm getting 4.1511. Okay, can even round this off to 3 significant figures. We're going to have 4.15. Okay, so that's what we have there. And you can see from my table there, I also found the same thing when I was solving this one here, 4.15. Okay, and then from there, if there are no questions, we can find the coefficient of variation. Okay, so the coefficient of variation is very easy to find. Okay, you just use the results that you've already found here. So there's no some complicated formula that you need to use. So the coefficient of variation, okay, CV is equals to the standard deviation, okay, divided by what did I write here? Okay, so here I wrote the variance, right? Okay, so here I'm supposed to put the square root like that. So I forgot the square root because on the calculator I put the square root because this was the formula for the variance, remember, right? So the variance we said 1 over this, then the summation of whatever. So I did 1 over 17, the sum of this, then I put the square root. So don't forget the square root there because that's the one that's going to give us the standard deviation. So if there's no square root, the number that I got before I got this was the variance. Okay, so don't forget that. Okay, and then now since we have the standard deviation, okay, we also have the mean, we can find the coefficient of variation. So coefficient of variation is equals to the standard deviation divided by the mean, then you multiply by 100. Okay, so in some textbooks, they don't multiply by 100, okay, because it will be the same, okay, to be the same thing. It's just that the other one is expressed as a percentage, the other one as a decimal, but the meaning is the same. So in some books, you see that they don't put the 100 there. They just say standard deviation divided by the x. Okay, so in this case, us will be putting the 100 there. So we want to find this coefficient of variation in terms of a percent. So the standard deviation was 4.15 divided by, the mean was like 9.06, and then I multiply this by 100. Okay, so what I find is approximately 45.84%. Okay, so that is my coefficient of variation. Okay, so I've actually found whatever we wanted here. So the mean, we found the median, the mode, the interquartile range, the mean deviation, the standard deviation, and the coefficient of variation. So I've shown you how to go about those. Okay, so for these data sets now, for this KCH, NGH, you can also do the same. You can use the same formulas that we are using. Okay, but the answer that you should get should be approximately equal to what I got in this table here. Okay, so it might differ maybe, okay, by just some to my decimal point. But the whole idea is that you get something that is closer to what I got as well, like that one. Okay, so these are the answers that you should get for KCH. Okay, for KCH, you should strive to get these answers. So just do the same thing that we're doing on the UTH. Even for the NGH, you should get these ones here. So based on these answers now that we have gotten, okay, we can answer part B, which says compare the variations, okay, of deaths in the 3 hospitals. So based on these values here, what can you say about the variations of death? Which hospital has a lot of death between UTH, KCH, and NGH? Which one do you think has a lot of death? Come on, guys. You can see the numbers there. So which one do you think has a lot of death according to the numbers that we have?
Is
Okay,
the NGH?
exactly. Okay, so you just take a look at the interquartile range, the mean deviation, the standard deviation, and even the coefficient of variation. So you see, starting at this column here, for the NGH, it is 9, the interquartile range. Okay, the mean deviation is 4.67. The standard deviation is 5.22, and the coefficient of variation is 58.05. So this is a very high standard coefficient of variation. Okay, it's a very high coefficient of variation, simply meaning that at this hospital, NGH, okay, there's a lot of variations in maybe the method that they use to treat the patients. Okay, it's not consistent. Okay, they keep on changing, and the result, people die a lot at that hospital. That's what it means there. Okay, so based on their variations, if we look at this coefficient of variation, we see that the NGH has the largest variation, which is 58 point something. Okay, and then UTH has 45, this KCH has 39. So it means at NGH, okay, there's a lot of deaths that are happening there because of the variation, maybe in the treatments, okay, and just the number of deaths that are taking place there. Okay, so to answer C now, which says which hospital needs a doctor urgently than all the others, okay, and then give a reason for your answer. So the hospital that will need a doctor urgently will be the one that has the highest what variation. It means a lot of people are dying there. Okay, so it means based on this data, we're going to say this NGH, okay, needs a doctor agent. Okay, so in case the meeting cuts, just join in using the same link. So we are done with question 2, unless you have any question there before we move to question 3. So is there any questions there? Okay, so if there are no questions there, then we move to question 3. So question 3 is, okay, so on question 3, they're saying a sample is selected from a population of 600 students to study age differences on newly enrolled students. Okay, A, if the sample has a mean age, okay, so the mean is 23, and as a sum of all the ages, so sum of all the x's as 1, 4, 2, 6, find the sample size. Okay, so this one is very easy. So we know that the mean is equals to the summation of all the x divided by the sample size. Okay, so we can make n the subject of the formula. So when we cross multiply, we have n, the mean, is equals to the summation of all the x. So this simply means what? Simply means that the the sample size is equals to the summation of all the x divided by the mean. So the summation is 1, 4, 2, 6 divided by 23. Okay, so when we divide this, I get 62. Okay, so the sample size, I've gotten that it is what? 62. Okay, so maybe we'll use it somewhere as we answer B and C. Okay, let's answer B. So B, they're saying, suppose the lower quartile is Q1, is 19 years old, okay? And the quartile deviation, okay, so quartile deviation is 4 years old. Find the upper quartile and the interquartile range. Okay, so we're trying to find Q3 and the interquartile range. Okay, so what is the quartile deviation? Okay, what is the quartile deviation? So most of you know the quartile deviation by the other name. So the quartile deviation is the same as the semi-interquartile range. This is the same as the quartile deviation. Okay, so the semi-interquartile range is simply 1/2, okay, multiplied by the interquartile range. But this interquartile range, we know it's what? Q3 minus Q1. Okay, so it means we have this formula here. So since we have the quartile deviation, which is the same as the semi-interquartile range, which is 4, okay, let me write here 4 is equals to 1/2. Then the Q3 we do not know. The Q1 is 19. So I can say cross multiply here. So it will be 8 is equals to Q3 minus 19. So it means my Q3 will just be 8 plus 19. Okay, so 8 plus 19 to give me what? 27, right? Okay, so it means my Q3 is 27. My Q1 is 19. I can find the interquartile range. Okay, or if you wanted, even without finding the Q3, you can still find the interquartile range. Because here, I have 1/2 interquartile range, and then it's equal in the quartile deviation. So the quartile deviation is 4, is equals to half, and then interquartile range. So if you want, you can just say cross multiply. So it means the interquartile range is equals to what? To 8. Okay, you can find it like this. But if you first want to find the Q3, okay, you can find it like the way we did. And then after finding the Q3, you can say my interquartile range is equals to the Q3, 27, minus the Q1, which is 19, which will just give me what? 8. Okay, so that is my interquartile range there. Okay, so I don't know if there are any questions there. Okay, and then this question C, okay, it's a question straight from your notes. Okay, it's about the skewness or the distribution. Oh, okay, what is the distribution showing? So depending on the values of the mode that you have, the mean and the median, okay, if they're going in a certain pattern, we can make a conclusion that the distribution is actually this type of skewness. Okay, it can be positively skewed or it can be negatively skewed. So let's get what we have here. Okay, so they have given us the values for the mean, for the median, and for the mode. Okay, so for the mode, they're saying the mode is 21 years old. The median, okay, is 22, and then the mean is what? 23. So what do we see here? Okay, we see that the mean, which is 23, is actually greater than the median, which is 22, and this median is greater than the mode, which is 21. Okay, so from there, what can we conclude? If the mean is greater than the median and it's greater than the mode, what can we conclude? Is our distribution positively skewed or it is right skewed? Anyone who can try, and then you also give an explanation why you think so. Is it positively skewed or negatively skewed? Based on what we have there. Okay, because I saw this in your notes. So I don't know if you passed through those notes. Okay, so there are two situations. So when the mean is greater than the median and is greater than the mode, okay, then we conclude that our distribution, okay, will be positively skewed. So the conclusion here is that this distribution is just positively skewed. Okay, or we can say it is right skewed or it is skewed to the right. So what does that mean? It means the tail of the distribution actually stretches to the right. Okay, so to put it in simple language, we can say there are some, because this data was based on the age differences you've seen there, right? Okay, so we can conclude based that there are some older students in the sample that will pull the average up. Okay, and then so the distribution is not symmetric. Okay, more observations are clustered at the lower age, which is 21. Okay, and then as we are going up there are just a few people. So that's what it will mean like this. So this data is positively skewed. So if you draw it on the graph, okay, if this is my level ground, if it is positively skewed to the right, so it will be like something like this. And then it has a long tail. Yeah, what's happening now? Then it has a long tail like this. Okay, so it means a lot of the young ages are on this side. So that's where you have your mode. Like a lot, okay, are to the side of the lower age here. And then we just have a few individuals that are older. No wonder the mean is being asked. The mean is 23 there. Okay, so the mean, if it's big, it will affect the distribution. Okay, to affect the distribution. So this is positively skewed. So in case they ask you about a left skewed distribution, okay, that one will look something like this. So it will be something like that, and then it goes higher. Okay, now I need to draw a smooth curve. I haven't drawn a smooth curve, so it will be like something like this, like that. So this one has a longer left tail. You can see this tail here is longer. So in this case, we have the opposite of what we have here. Okay, if it is left skewed, then it will mean that the mode Okay, the mode is greater than the median, and the median is greater than the mean. So you have to master these situations because they can bring them. Okay, so imagine now you're failing these simple questions here. What about those you are drawing polygons? Now you're doing frequency tables. It's going to be hard. So these ones, master them. Okay, so if the mode is greater than the mean, the mode is greater than the median, greater than the mean, then it means that your data is left skewed. Okay, it's negatively skewed. If the mean is greater than the median, median is greater than the mode, then you have a positively skewed. All right, so any questions there, guys? Okay, so if there are no questions, I'll end here, but I'll still make videos to solve the other questions uh, that I solved already, but the video doesn't have any sound. So I'll make time to solve all these other questions here. So right now I solved 1, 2, 3. Okay, so I'll remake the videos for all these other questions there. Right, so thank you so much for attending. We end here for today.